8.2. Now let's take a look at the distribution of the sample proportion. Last time we looked at the sample mean, now we're looking at sample proportion. Alright, so suppose that a simple random sample of size n is drawn from a population in which each individual either does or does not have a certain characteristic. Then the sample proportion, which we call p hat, is given by x over n, where x is the number of individuals in the sample with the specified characteristic, and again, n was the sample size. So the sample proportion, p hat, is a statistic that estimates the population proportion, or the proportion of the population that has that characteristic. So let's compute a sample proportion. So we have 1,745 registered voters that were asked if they approved of the way George W. Bush was handling the economy. 349 of the voters responded with a yes. So we're going to obtain a point estimate, which is basically your sample proportion, for the proportion of registered voters who approve of the way he was handling the economy. So we take 349, divide by 1,745, and we get 0.2, about 20%, and that is your sample proportion, also called the point estimate. Now let's take a look at describing the distribution. A poll was taken and 42% of registered voters believed that gay and lesbian couples should be allowed to marry. Describe the sampling distribution of the sample proportion for samples of size 10, 50, and 100. Now keep in mind we're using simulations to create these histograms, so they could be done on the calculator or using StatCrunch, but we're using simulations. We didn't actually take these samples. All right, so here is the histogram for when n equals 10. Here's the histogram for when n equals 50, and this histogram for when n equals 100. What do you notice is happening here? It's getting closer and closer to a normal distribution. So look at the shape. As the size of the sample n increases, the shape of the sampling distribution of the sample proportion becomes approximately normal. The center, the mean of the sampling distribution of the sample proportion, equals the population proportion. And the spread, the standard deviation of the sampling distribution of the sample proportion, decreases as the sample size n increases. So your shape becomes closer and closer to normal. Your mean is going to equal the population proportion, and your standard deviation is going to decrease. All of these things happen as your sample size gets larger. So for a simple random sample of size n with population proportion p, we know that the shape of the sampling distribution of p hat is approximately normal as long as when you multiply the sample size and the population proportion together, and then you multiply that by 1 minus that proportion, your number is going to be larger than or equal to 10. Also, we want to make sure that we are not taking a sample size that is larger than 5% of the population, because then we no longer have independence. The mean of the sampling distribution of p hat is really just your population proportion. And then the standard deviation is when you take the square root of your population proportion times 1 minus that proportion, all divided by your sample size. And you're taking the square root of the whole thing. So let's take a look at an example. We're back to the same problem. Suppose we obtain a simple random sample of 50 voters. Determine which voters believe that gay and lesbian couples should be allowed to marry. Describe the sampling distribution of the sample proportion. So the first thing we need to do is make sure that our sampling distribution is approximately normal. Then we determine what the mean is, and that was just your population proportion. So that was the percentage that they gave us in the original problem. And then we can find our standard deviation. And so in order to describe the sampling distribution, we know that it's approximately normal, we know that the mean is 0.42, and we know that the standard deviation is 0.0698. So now let's compute some probabilities. 18.8% of school-aged children were overweight in 2004. So in a simple random sample of 90 school-aged children, aged 6 to 11 years old, what is the probability that at least 19% are overweight? And then we're going to look at a random sample of 90, and the random sample gave us 24 overweight children, so then we're going to determine what might we conclude. All right, so the first problem, we make sure that we have a normal distribution, which we do, and we know that our mean is 0.188, because that was the population proportion given to us in the original problem. And then we find our standard deviation, which was 0.0412. So back to the original problem, what is the probability that at least 19% are overweight? So we need to find our z-score. So we take our 0.19, because that's our x, minus our mean, all divided by the standard deviation, and we get a z-score of 0.0485. So when you're looking at the table, you can just look for 0.05. And then we want greater than 0.05, so we need to subtract that area that we get. When we look at that z-score, we need to subtract that from 1 in order to get the correct probability. Now let's take a look at the second part of the problem. Again, same thing as before. We have a normally distributed sample, and our mean was 0.188 and our standard deviation was 0.0412. So now we want to see what we can conclude if we get 24 overweight children out of a sample of 90. So our p-hat, our sample proportion, is 0.2667. So we look at the z-score for that, and we get 1.91. And then we look at the probability of a z that's greater than 1.91. So again, we're going to need to subtract from 1. And we get 0.028. So we would only expect to see about 3 samples if we took 100 samples. That would result in 26.67% or more children that are overweight. So this is an unusual sample if the true population proportion is actually 18.8%. And so that is how we take a sample proportion.